All right, let's jump right in. If you've ever built a modern application, you have absolutely run into this classic problem. How do you handle all those background tasks without letting them drag your main server to a screeching halt? Today, we're going to break down the two main paths you can take to solve this exact issue. So let's set the scene. Your app is a huge success. That's great, right? But now traffic is spiking and your web server, the thing that's supposed to be giving users instant responses, is getting totally bogged down with heavy, slow background jobs. So the big question is, how do you offload that work and keep your system from, well, completely falling over? And believe me, this isn't just some theoretical exercise. This is a real-world headache that developers are dealing with every single day. This quote from a Reddit thread just hits the nail on the head. You've got your main API server, and you desperately need to get those slow asynchronous tasks running somewhere else. It's the classic battle. When you really boil it all down, you're faced with two fundamental choices in your architecture. We're going to call them the direct call, which is a tightly coupled approach, and the mailbox, which is a loosely coupled approach that uses something like Amazon's SQS. So let's unpack what that all actually means. Okay, first up, we have path A, the direct call. Now, this is probably the most intuitive way to think about the problem. It just makes sense, right? Your web server needs a job done, so it just calls another service or function and tells it to get to work. And this is exactly what we mean when we say tightly coupled. The different parts of your system know a lot about each other. The web server has to know the exact address and the specific API of the worker it needs to call. They're directly linked, they're dependent on each other, and as we'll see in a minute, that has some serious implications. The flow itself is really straightforward. A request comes in, the server immediately fires off an asynchronous call to a worker, and that worker starts its job right away. Simple, direct, and you know what? For some use cases, it's perfectly fine. But what's the alternative? And that brings us to path B, which we're calling the mailbox. Now, this approach introduces a middleman, a message queue, to decouple our services. And this idea of decoupling is the absolute key to building a system that's truly resilient. This whole approach is really the foundation of event-driven programming. Instead of one service calling another directly, the server just drops a message, like a little note, into a shared mailbox or a queue. Then the worker can just come and check that mailbox for new messages whenever it has the capacity to do more work. And the beautiful thing about a queue is its simple rule. First in, first out, or FIFO. It's just like standing in line. The very first message that gets posted into the queue is the very first message that gets picked up for processing. It keeps everything fair and totally predictable. So you can see the flow here is completely different. The web server's job becomes incredibly simple. It's just fire and forget. It tosses a message into the SQS queue, and that's it. Its job is done. It doesn't know or care which worker picks it up or even when it gets picked up. The worker just operates independently, pulling jobs from the queue at its own pace. Okay, so we have our two contenders, the direct call and the mailbox. Now it's time for the showdown. We're going to put them head to head on the three things that matter most when you're building a serious system: scalability, resilience, and control. First up, scalability. With a direct call, a sudden spike in traffic means you are directly hammering your worker functions, which in turn are hammering your database. You can easily exhaust all your resources. But the mailbox approach with SQS, it acts like a giant shock absorber. It can soak up a massive flood of requests and just hold them, letting your workers process them at a nice, steady, sustainable pace. I just love how this user on Reddit describes it. They call SQS a bottomless pit. It's such a perfect image. You could throw a million jobs at it, and it'll just sit there patiently, holding on to them until your system is ready to chew through that workload. Next round, resilience. Because let's be honest, things are going to fail. With a direct call, if that worker function crashes mid-process, that task might be gone forever, unless you've built some really complex retry logic. With SQS, if a worker fails, it's no big deal. The message just becomes visible in the queue again, ready for another worker to pick it up. A failure in one little part of your system doesn't cause a catastrophe for everyone else. And finally, let's talk about control. Visibility. When you're making direct calls, you're basically flying blind. How many tasks are backed up? Is the problem getting worse? You have no idea. SQS, on the other hand, gives you this beautiful dashboard with clear metrics. You can see exactly how many jobs are waiting, how old they are, and how fast you're getting through them. You are back in control. This comment from that same thread just nails it. They point out that even if you try to limit your function's concurrency, without a queue, you have zero insight into the backlog that's piling up behind it. Is the workload growing? Is it shrinking? You can't answer those crucial questions. SQS gives you the tools to see what's really going on. So, after that showdown, which path should you choose? Well, as with pretty much everything in software architecture, the answer is it depends on the job. Let's look at a quick guide to help you decide. Think of this table as your cheat sheet. If your tasks are super simple and need to run immediately, a direct call can be fine. It's less complex, a little faster. But for almost everything else, if you have unpredictable traffic, if the work is critical and can't be lost, or if you need to protect a fragile database, the mailbox approach with SQS is by far the safer and more scalable choice. So here's the crucial point. There is no single best answer. The choice between a direct call and a queue is a fundamental trade-off. You're balancing the simplicity of a direct call against the incredibly powerful guarantees of scalability, resilience, and control that you get from using a queue. And that really leads us to a final, bigger question. The entire software industry is moving away from giant monoliths and towards event-driven microservices. In that world, decoupling and resilience aren't just nice-to-haves. They are absolutely essential. So the real question to ask yourself is, how are you going to design your next system to not just work, but to survive?